Imagine a spacecraft making its daring plunge into the unknown, a death dive into the atmosphere of a distant planet. That was the fate of Cassini, the space probe that became a legend. This is the story of Cassini, an unmanned spacecraft that journeyed to the second largest planet in our solar system, Saturn. An ambitious project by NASA, the European Space Agency, and the Italian Space Agency, the mission was designed to study Saturn's system in detail over the course of 13 years. On October 15, 1997, Cassini launched from Cape Canaveral, Florida, embarking on a nearly 7-year journey to Saturn. Propelled by a combination of rocket engines and gravity assists from Venus, Earth, and Jupiter, the spacecraft traveled over 2 billion miles to reach its destination. Upon arrival in July 2004, Cassini began its primary mission. It carried out detailed studies of Saturn's rings, moons, and magnetosphere, transmitting breathtaking images and valuable data back to Earth. Its most significant discoveries included detecting water plumes on Enceladus and exploring the methane lakes of Titan, Saturn's largest moon. Throughout its mission, Cassini exemplified the spirit of exploration and discovery. The scientists and engineers behind this project demonstrated remarkable bravery and pioneering spirit, pushing the boundaries of human knowledge and technological capabilities. On September 15, 2017, Cassini performed its grand finale. After a series of daring dives between Saturn and its rings, the spacecraft made its final descent into the planet's atmosphere. This was no accident, but a planned end to the mission, ensuring that Cassini would not contaminate Saturn's moons with earthly microbes. As it plunged, Cassini transmitted data until the very end, providing scientists with unique insights into Saturn's atmosphere. Then it burned up like a meteor. Its mission completed, its life ended, but its legacy enduring. As Cassini met its fiery end in Saturn's atmosphere, it left behind a treasure trove of discoveries that continue to astound us. Saturn, the Lord of Rings, holds a mesmerizing ballet of icy particles, and Cassini was invited. The Cassini mission, a collaboration between NASA, the European Space Agency, and the Italian Space Agency, gave us a front-row seat to this celestial performance. What we saw was an intricate dance, a swirling spectacle of countless icy particles, each one a tiny dancer in Saturn's grand ballet. Cassini's cameras captured these rings in unprecedented detail, revealing a complexity and beauty that left us in awe. Unlike the dusty rings of Jupiter, Uranus, or Neptune, Saturn's rings are composed of water ice. The size of these icy particles can range from tiny grains to huge chunks as large as mountains. Saturn's rings are not just beautiful, they are also a window into the history of our solar system. They offer clues about the processes that led to the formation of planets and moons. Cassini's dance with Saturn's rings revealed a cosmic spectacle of unparalleled beauty. Beneath the icy surface of Enceladus, a moon of Saturn, Cassini discovered a world alive with activity. Picture a moon, its surface covered in a blanket of ice, seemingly lifeless and unchanging. But beneath this icy exterior, an unexpected surprise awaited the Cassini spacecraft. As it journeyed past Enceladus, one of Saturn's numerous moons, it stumbled upon a remarkable discovery: geysers of water vapor erupting from the moon's surface into the cold void of space. These water plumes were not merely an interesting spectacle. They suggested the presence of a subsurface ocean hidden beneath the moon's frozen crust. This was a groundbreaking discovery. Before Cassini, our understanding of moons was that they were lifeless, barren, and inactive. But Enceladus was different. It was active, it was dynamic, and most importantly, it had water. Now, why is this significant? Well, water is a key ingredient for life as we know it. Here on Earth, wherever we find water, we find life. So, the discovery of water on Enceladus immediately shifted our perspective on where life might exist in the universe. It opened up the possibility that life could exist in the most unexpected of places, even on a tiny, icy moon orbiting Saturn. But the story doesn't end there. Further analysis of the water plumes revealed that they contained organic molecules, the building blocks of life. This doesn't necessarily mean there's life on Enceladus, but it does mean that the moon has some of the necessary conditions for life to exist. This discovery has profound implications. It means that our search for life is not just limited to planets in the so-called Goldilocks zone, where conditions are just right. Instead, we can broaden our horizons, looking for life in places where we might never have thought to look before. Cassini's discovery on Enceladus has transformed our understanding of where life might exist in the universe. It has shown us that even in the most unexpected places, amidst the icy moons and giant gas planets, life might find a way. With its geysers of water, Enceladus is a shining beacon in our search for life beyond Earth. On Titan, Saturn's largest moon, Cassini found a world eerily similar and vastly different to our own. It's a place where the familiar and the alien dance a cosmic ballet, where rivers and lakes abound, not with water, but with methane. Welcome to Titan, a world that has held scientists and space enthusiasts spellbound since Cassini's first detailed images. This moon, larger than the planet Mercury, is the only celestial body in our solar system, apart from Earth, where clear evidence of stable bodies of surface liquid has been found. But don't pack your swimsuit just yet. These aren't the serene blue waters of our earthly lakes and oceans. Instead, Titan's lakes are filled to the brim with liquid methane and ethane. Yes, you heard that right. This moon, shrouded in a thick orange haze, has lakes filled with natural gas. It's a chilling minus 290 degrees Fahrenheit out there, a temperature so low that methane, which we know as a gas, exists as a liquid. These methane lakes could help us understand more about our own planet. How? By acting as a prebiotic chemistry lab. Scientists believe that Titan's frigid environment with its complex organic molecules may mirror the conditions that led to the emergence of life on Earth billions of years ago. But the methane mystery deepens. Titan's methane should have been depleted long ago, yet its atmosphere is still rich in this compound. This has led scientists to postulate an intriguing theory. Could there be a methane cycle on Titan similar to the water cycle on Earth? Could there be methane reservoirs deep beneath Titan's surface? Or does Titan have methane-producing organisms, much like Earth's methane-producing bacteria? As we delve deeper into the secrets of this fascinating moon, we are reminded of the words of Arthur C. Clarke. Two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. From its methane lakes to its orange, hazy skies, Titan remains a world of mystery and wonder. At Saturn's North Pole, something strange and geometric resides, a six-sided hurricane, a hexagonal storm. This unusual storm was first detected by NASA's Voyager spacecraft in the early 1980s and later confirmed by the Cassini mission. It's a hurricane with a twist, literally. Instead of a circular eye that we're accustomed to seeing on Earth, this storm has a hexagonal one. This geometrically precise storm stretches around 20,000 miles across, with winds whipping around at speeds of 200 miles per hour. The existence of such a storm challenges our understanding of atmospheric physics. It's an enigma that continues to puzzle scientists as they try to comprehend how such a peculiar shape can be maintained in the chaotic and turbulent atmosphere of a gas giant like Saturn. The discovery of the hexagonal storm has offered new insights into Saturn's atmospheric conditions, raising more questions than answers in the process. The hexagonal storm, a geometric enigma, continues to baffle and intrigue scientists. In the shadowy realm of Saturn's rings, ghostly structures lurk, seen only by the ever-watchful eyes of Cassini. These structures, known as propellers and spokes, are an enigma that have captivated scientists since their discovery. Propellers are intriguing formations, a result of a gravitational tug-of-war between tiny moonlets and the icy particles that make up Saturn's rings. These moonlets, no larger than a few kilometers across, cause the particles to shift, creating these distinctive propeller-shaped gaps. Spokes, on the other hand, are temporary features, mysterious radial formations that seem to come and go with Saturn's day-night cycle. Composed of fine icy particles, these spokes are believed to be influenced by Saturn's magnetic field. In studying these phenomena, we begin to understand the dynamic environment within Saturn's rings. Each discovery, each image, unravels a new layer of complexity and beauty. These ghostly figures dancing in Saturn's rings are yet another testament to the dynamic nature of our universe. Let's revisit Cassini's grand finale, the daring plunge that revealed secrets until its very last moment. As we recall, Cassini deliberately met its end in the atmospheres of Saturn, but it was not a futile end. Even in its final moments, this brave explorer was gathering data, sending back a wealth of information that scientists are still deciphering today. During its descent, Cassini pierced through the outer layers of Saturn's atmosphere, a region where no spacecraft had ventured before. It measured the atmosphere's composition, temperature, and pressure. Cassini discovered that Saturn's atmosphere is predominantly hydrogen, with traces of helium and methane. But what truly surprised scientists was the abundance of heavier elements, a finding that challenged our understanding of Saturn's formation and evolution. Cassini also discovered unexpected atmospheric phenomena. It detected equatorial winds that reach speeds of up to 1,100 kilometers per hour, making them some of the fastest in the solar system. And it observed lightning deeper within Saturn's atmosphere than previously thought possible. The spacecraft's instruments detected a mysterious haze of molecules heavier than methane high in the atmosphere, suggesting complex chemistry at work. This finding, among others, has spurred a new wave of research and speculation about the potential for life on gas giants. Amidst all of this, Cassini's grand finale was much more than a scientific mission. It was a testament to human curiosity and our relentless pursuit of knowledge. Cassini's daring plunge into Saturn, its final act of exploration, represents a pinnacle of human achievement, a moment that resonates with the spirit of discovery that drives us to explore the stars. In its final act, Cassini painted a picture of a world far from home, forever etching its legacy in the annals of space exploration. Even in its ultimate sacrifice, it left us with a trove of data, a legacy that continues to fuel our understanding of Saturn, its moons, and the vast, mysterious cosmos beyond. The echoes of Cassini's discoveries continue to reverberate throughout the scientific community. The Cassini mission, one of the most ambitious and successful ventures in the annals of space exploration, has left a lasting legacy that continues to shape our understanding of the universe. This was not just a journey to Saturn, but an odyssey that has broadened our horizons in ways we could have only dreamt of. The mission's top discoveries have been nothing short of monumental. The ethereal dance of Saturn's rings, captured in stunning detail, revealed the dynamic nature of these celestial bodies. We now know that these rings are more than just beautiful. They are complex ecosystems, teeming with moonlets and constantly evolving. The revelation of water geysers erupting from the icy surface of Enceladus was a game-changer. It raised the tantalizing possibility of life existing beyond our home planet. This icy moon, once thought to be a frozen and lifeless world, is now considered one of the most promising locations in our solar system for the search for extraterrestrial life. The exploration of Titan, Saturn's largest moon, has been equally astounding. The discovery of vast methane lakes on its surface has challenged our understanding of what alien worlds can look like. It has also sparked intriguing discussions about the potential for life in environments vastly different from our own. And let's not forget the hexagonal storm at Saturn's North Pole, a phenomenon as strange as it is captivating. This bizarre six-sided vortex, larger than two Earths, has raised intriguing questions about the nature of weather on other planets. These discoveries, and many more, have forever changed our perception of Saturn and the wider universe. The echoes of Cassini's findings continue to inspire new questions, drive new research, and fuel our insatiable curiosity to understand the cosmos. Cassini's legacy lives on, reminding us that in the vastness of space, there are always new mysteries to unravel and new horizons to explore. As we wrap up our journey through the astonishing revelations of the Cassini mission, we invite you to join us in our exploration of the celestial wonders. If you've learned something new today, if your curiosity has been piqued, we encourage you to engage with us. Give this video a like, share your thoughts in the comments, and don't forget to subscribe and press the bell icon for more enlightening content. The cosmos is a vast, fascinating place, and every shared insight brings us closer to understanding its grandeur. As we stand on the precipice of the known and the unknown, let's remember Cassini's legacy. It's a testament to our thirst for knowledge, our capacity for discovery, and our insatiable curiosity. So pass on this cosmic journey to your friends and families, inspire them with the wonders of our universe, and together, let's continue to unravel the mysteries of the cosmos.